Today, we talk about model-based system engineering using SBC process algebra. I'm Dr. William S. Chow. Chapter 1. What is document-based system engineering? Document-based system engineering is characterized by the generation of different textual analysis, design, test, etc. document that will be used for customer, user, developer. Secondly, all this system analysis, design, test information are expressed in these documents. Third one, the system engineering will emphasize how to control this documentation and ensuring all the document drawings are very consistent. Chapter 2, let's go to what is model-based system engineering. Model-based different from document-based because we only have one single model, one coherent model for all this system analysis and system design and system test, such and such. For model-based system engineering, we really need the system model. SYSML currently is the most well-known system model for model-based system engineering. SYSML is defined as an extension of a subset of the UML using UML profile mechanism. Chapter 4 talk about the problems of SYSML. SYSML use many different diagrams, and there are inconsistencies between these diagrams. Therefore, SYSML need a meta model to ensure consistency between these SYSML diagrams. However, this SYSML meta model is very complex and does not integrate the static structure and dynamic behavior. Now, let's turn to SBC process algebra. SBC stands for structural behavior correlations. And SBC process algebra really integrate the structure and behavior. So, SBC process algebra is really the best system model for model-based system engineering. In SBC process algebra, an operational call or return signature is a combination of its name along with parameters. And each parameter in the list is displayed with direction, parameter name, and parameter type. There are two different kinds of interaction. Type 1 interaction is an interaction between an outside actor with the COE component. And type 2 interaction is an interaction between the caller component and the COE component. And the SBC process algebra consists of many states. Also, a finite set of type 1 or 2 interaction with A1 or A2 to range over it. Also, we have a transition relationship, like from SI state transit to Si state J through interaction A. And the semantics of SBC process algebra is described by a state machine diagram. In this state diagram, we see S00 is the initial state, and each A11, A12, such and such are type 1 or 2 interactions. Now let's have the conclusions. We say SBC process algebra really integrate the structure and behavior within a state machine diagram. Secondly, SBC process algebra is very simple without much complexity. The third one, there are only one state machine diagram. Therefore, there's no inconsistency between different diagrams because in SBC process algebra, we only have one single diagram. That is, we really conclude that SBC process algebra is the best system model for model-based system engineering.